Now let's take a look at hypothesis testing errors. And there's two types that we're going to consider. The first type is rejecting the null when it is true. The second type is failing to reject the null when it is false. For example, let's say we make a claim. The population mean age is 50. That becomes our null hypothesis. The mean is equal to 50. So this is the population that we then draw a sample from to test this claim. Let's say our sample mean is 20. Now, is a sample mean of 20 likely if the population mean is 50? Well, of course, we would do our statistical analysis using either the critical value approach or the p-value approach. But let's say we do so and we end up rejecting the null, which essentially means that based on our sample mean, it is not likely that 50 is the true population mean. Down here, for example, we're hypothesizing that the mean is 50 right here, but then we collect a sample mean that is way over here. And therefore, we reject the null. If, however, the null is true, then we've rejected the null and we're wrong. That is a type 1 error, rejecting the null when it is in fact true. And the only time that you would reject the null is if you get a sample mean that is in the rejection region. Now, how often would that happen? Well, if the population mean is in fact true at 50, then we would expect to get sample means in the rejection region level of significance percent of time, because the level of significance defines the areas in the rejection region. If we have a 5% level of significance, then this bottom tail would be half of that, 2.5%, and this top tail would be half, 2.5%. 2.5 and 2.5 would be 5%. So we would get a rejection of the null anytime we got a sample that is in the tails, that is 5% of the time. So to summarize type 1 errors, they occur when the null is true, but we reject it. That's a type 1 error. True null, but we reject it. And the probability of this occurring is the level of significance, alpha. Now let's talk about type 2 errors. This is failing to reject the null when the null is false. Let's say that we collect the same data, okay, and in this case, we get a population mean of 50. That's our hypothesis, but it's wrong. It's false. The population mean is a different value. And when we collect our sample, we get a value that is not in the rejection region. So we fail to reject the null, even though it is false. In that case, we have a type 2 error. The null is wrong. The population mean is not equal to 50. But when we do our test, we conclude that there is no reason to reject the null. We conclude that the mean is equal to 50, type 2 error. Now let's move on to an application. It says the label on a 3-quart container of orange juice states that the orange juice contains an average of 1 gram of fat or less. Answer the following questions for a hypothesis test that could be used to test the claim on the label. Let's move over to the DocCam to do this. Describe the appropriate null and alternative hypothesis. Well, the narrative tells us that this is going to be an inequality, right? Because it says that the label states that orange juice contains an average of 1 gram of fat or less. Note that the 1 gram or less implies that's our null, because a null always has an equality in it. So we put null hypothesis as the mean is less than or equal to 1 gram. And that defines the alternative, which is that the mean would be greater than 1. Okay, now let's consider the types of errors that could occur. And to do this, let's just consider all possible outcomes and see which ones might qualify as errors. So one possibility is that we collect our sample, okay, and we fail to reject the null. That could happen, right? We collect our sample and we fail to reject this. If in fact, though, the null is true, then we would be failing to reject the null, and the null is true. So that's not an error. We put a star here. That's a good test. We did exactly what we should do. What if instead we fail to reject the null, and the null is false? So we fail to reject this, but it's wrong. Okay? In that case, we would have a type 2 error. Type 2 error there. We want to avoid that. Okay? What if we reject the null and the null is false? Well, we would reject this, but it's wrong. So that's what we want. That's good. That's not an error. But if we reject the null and the null is true, then we've rejected this and it's right. So that's a type 1 error. So I think it helps to consider all the possible outcomes that could occur from the test and see that really only 2 of them are going to be potential errors. Okay, now let's move on to the next one. It says, if the null hypothesis is false, which type of error would be impossible to make? Well, let's consider what could happen if the null is false. If it's false, let's just use this as an example. So if this is not true, the mean is not less than or equal to 1, then we could either reject that or not reject it, which would be a fail to reject. Okay? If the null is false and we reject it, then that's good, right? That means we're doing what we're supposed to do. But if the null is false and we fail to reject it, we're failing to reject something that's not true. So that would be an error, and that would be a type 2 error. So clearly a type 2 error is possible, which means that a type 1 is not. For a type 1 error, you would actually need the null hypothesis to be true. This would have to be correct, and then you would have to reject it. Let's move on to the next one. It says, as the level of significance increases, which type of error increases in probability? Okay, let's go ahead and draw this one out to get a better sense of what's going on. We know that we have a normal distribution of sample means. And based on our hypothesis here, we'll just use this one again, we're contending that the mean is less than or equal to 1. We're contending that the population mean is either equal to 1 or somewhere down here in this area. This, therefore, becomes a upper tail test. The rejection region would be up here, and that rejection region is going to be based on the alpha level of significance. So let's start out and say it's 5%, which is very typical. So this tells us that if the true population mean were less than or equal to 1, we would expect to reject that 5% of the time. We would expect to get sample means that would be up here and cause us to reject the null hypothesis. But the null hypothesis would be true. So 5% alpha is the probability of getting a type 1 error. Okay. If we increase the alpha, let's say we go to 10%, then this now becomes 0.10. And the probability of committing a type 1 error, rejecting the null when it's true, goes up to 10%. So as the level of significance increases, type 1 errors increase in probability. Let's move on to the next one. It says, assume the unemployment rate is 8% in the economy. You conduct a hypothesis test that rejects the null of the unemployment rate being 5%. Did you commit an error? If yes, what type? Let's set up our hypothesis test. So we know that the null is going to be that the unemployment rate is equal to 5%. And the alternative is that the unemployment rate is not equal to 5%. From there, we can recognize that the actual unemployment rate is 8%. We rejected the null that it's 5%. So we rejected the null that was wrong. The null said the mean is 5%. The actual unemployment rate is 8%. So we did not make an error here. This is the correct outcome. Let's move on to the last one here. It says, assume the average wage of manufacturing workers in the US is $29 per hour. You conduct a hypothesis test that fails to reject the null of the wage being $20 per hour. Did you commit an error? What type? Well, again, we're going to define our null and our alternative. The null here would be that the wage is equal to 20, so the mean is equal to $20. And the alternative would be that the mean is not equal to $20. Okay. Well, the average wage of manufacturing workers in the US is $29, and we failed to reject the null. Therefore, we essentially said that the mean is equal to $20 because we didn't reject this. That is a type 2 error. Remember, a type 2 error occurs when we fail to reject the null and the null is false. Here, we failed to reject the null and the null of $20 is false because the true average wage is $29. Okay, that's it. Let me know if you have any questions. Thanks.